Okay, when it comes to solving multi-step equations, we're dealing kind of with two-step equations, and then the rules continue to apply further and further, okay? So when it comes to these, we have to think about our order of operations, okay? A lot of times we do the PEMDAS, please excuse my dear Aunt Sally, okay? And those are the order of operations, or hopefully we've advanced a little bit more to GERMDAS, I don't know, hopefully, okay? When we do that, it's important that we know the direct way and then the opposite way, okay? So we do the direct way for simplifying our expressions. Once we've simplified everything as far as we can, then we need to actually go backwards because we're undoing. Okay, so in our one-step equations, we had addition and subtraction opposite each other, and we'd use it to help solve. Multiplication and division opposite each other, we'd use it to help solve. Okay? Now we're going to do our order of operations opposite each other. So this is where we undo, starting with addition and subtraction first, then we undo our multiplication and division. Now remember, they're tied, just like in our order of operations, addition and subtraction are done at the same time. So if there's multiple ones of them, we're going to do them at the same time. But if we've done a good job of simplifying our expressions, there should only be one of each of these operations to happen. Okay? So we're going to get setups like this. So we have 4x plus 3 equals 11. Now this setup, fairly small, simple equation, okay, but will look pretty massive for students in their first time. As I look at this, I need to undo addition and subtraction first. So I look for all the addition and subtraction and I work to undo it. Minus 3, right? We want it to go to 0. Minus 3. Got to do it to both sides. Keep it even, keep it equal. Now 4x is really being plus 0, but do I need to write a plus 0? Nope. That's the beauty of it. 4x equals 11 minus 3 is 8. Okay? Now I've got a one-step equation. Divide by 4, and x is going to equal 2. Okay? So these setups are really smooth and easy for us to do. Okay? Now, here we've got another one. Subtraction's being done, no addition, so we're going to undo our subtraction. So here, we're going to add 5 to both sides. Okay? That gets me 0 and 12. 3x plus 0 is the same as just 3x. Divide by 3, divide by 3. X equals 4. Okay? So these especially aren't too bad. We just get used to undoing my addition and subtraction, then dividing. You know, it's the two one-step equations combined. Okay? Over here, we've got some division going on. So just like in the previous, I work to add my 8, okay, 91 over x equals 13. Ugh. Okay, I've got that x on the bottom. So this isn't really a one-step equation. One operation is happening, but it's going to take more work for me to undo this. Okay, I've got to times both sides by x. These will cancel each other out. And I get 91 equals 13x. Now I can divide both sides by 13, and I get 7 equals x. Okay, again, not the direct order that we may be used to, but there's no good reason to tell them not to. Okay? X divided by 5 plus 7 equals 5. So now I go to minus 7 for both sides, and I get x over 5 equals, 5 minus 7, this is going to be a negative 2. Okay? Make sure that we keep the sign correct in all of this methodology and work that's being done. Okay? Making sure that that sign is correct means that our whole equation works out. So we're probably going to have a negative answer. We need to be more comfortable with negative answers. They happen, and there's nothing wrong with them. Okay? So here we have that negative answer that we know is coming for us. Okay? We're going to time both sides by 5. These will cancel each other out. Big 1. X equals negative 10. And there we go. Okay? So each of these, even though some of them were a little bit more work than we thought they would be, getting negative answers, all those still work on the same rules. We undo our addition and subtraction, then we undo our multiply and divide. Okay? If we get back all the way into exponents and parentheses, yeah, we'd undo each of those in their turn with the opposite order of operations.